Hello everyone, my name is Hadhrami Ghani. I'm a PhD holder graduated from Imperial College London, and my interest currently is data science, and today I'm going to present to you a very important topic that will be of your interest. So the first one that I'm going to tell you is basically about COVID-19 pandemics. So I have only three important and brief points that I'm going to share with you. The first thing is whatever that I'm going to say today is actually based on a very reliable data set, and what I will present to you further is what I have done in order to analyze the data set and what are my findings that I'm going to share with you. So the analysis that I've done is basically in predicting the COVID-19 pandemics, and you know COVID-19 pandemics is still going on, and the effects of these pandemics is huge, and it is affecting everyone. And finally, I'm going to share with you the solutions that I have gained in brief. So the data set that I'll be showing to you is basically obtained from the Center of System Science Engineering in Johns Hopkins University. This university, and I think there are many other universities as well, are doing research in this COVID-19, and we know that the data about COVID-19 is very important for us, and it needs to be validated, it needs to be updated from time to time, and this is what is going on with this university. It keeps updating the data, and I have been using this data for this finding that I'm going to share with you, and it is also available to the public, as you can see from the GitHub link here. And let's go briefly about the importance of predicting the pandemics. We know that the pandemics are affecting almost everyone, and some of the most affected ones are the elderlies, the kids, the people with poor health conditions, and the health ministries who are dealing at the front line to get over this problem. And there are many affected companies because of this pandemics. So the result and the findings that I'm going to tell you will be a very important stepping stone for us to know and to prepare for this after effects of the pandemic. And there are three solutions that I'm going to tell. Basically, the first one is about the data measurement. Based on the data set that we have gained, we will tell you how we measure the data in order to find the important features of the data. And this is what we call as time series data, and there are many correlations between each other, and we need to consider the time and the temporal relationships in order for us to predict these pandemics. And finally, in the third notebook, I'm going to share the modeling and the training that I have done on this data set. So let's go into a detailed discussion in a very short time here. So this is a data science project. Whatever we talk about data, then we need to be very sure what are the data that we are working on. So there are basically four things that I'm going to tell you today. First is about the architectural choices that I have made in order to complete this data science project, and then I'm going to show to you the data quality assessment that I have done, the data pre-processing, and the feature engineering. And then thirdly, I'm going to show you the model algorithm that I have been using, and then finally I will share with you the performance indicator. The architectural choices that I have made based on the given guideline from IBM, there are roughly 9 here. Firstly, as we know, is about the data source. So I have taken the data from the Johns Hopkins University, which are prepared in .csv format, and it is very convenient to process this kind of format of data in Jupyter Python notebook. And then as for enterprise data, currently I'm taking IBM as the source of enterprise data, and although I'm not taking any data yet from IBM, but I will keep definitely and share the data with IBM Cloud Storage. And the stream analytics, because this data science project is about time series data, and we know that it is being updated from time to time, so I need to use both real-time processing as well as batch processing. And the data integration, the framework that I'm using is basically from pandas, because the data frame format is very good, and as well as Spark data frame also is a very good option, and which I have used in my data science project. And then the data, after it has been cleansed and measured and visualized and cleansed, so we upload the data, we store the data in the IBM Cloud Object Store in Parquet format. As we know, Parquet format is a very good format. It is in column form, and it is very easy for us to access it whenever we want to process and train the data. And the next thing is about the discovery. We are using the supervised machine learning. Okay, we are using LSTM, the long short-term memory, and we are also using another non-deep learning method, which is logistic regression. Okay, and then basically what we're going to do and share with you today is the report, the notebook reports that we have produced as a completion of those tasks in order to complete this data science project on predicting the COVID-19. The data and feature is a very important thing to do, so we have done the measurements and the visualizations by using the mean, minimum, maximum skewness, kurtosis formulas. And because this is a time series data, we also use the time steps, because we need to consider the temporal relationship between the data, as this is a time series data. And we also use the number of confirmed cases in order to complete this project. Okay, we can see here, as we can see here, from week 1 data measurement. Okay, this is what I have done from my first output, okay, of the data science project here. I have basically installed the PySpark and obtained the data, okay, from the Johns Hopkins University, as you can see here. And then I have imported and save it in pandas, and I've tried to visualize some of the basic visualizations here, and then I try to cleanse the data, okay, by removing some of the empty stuff here, the null, and then I convert it to the Spark data frame here in order for me to process better. And then I change the name of the column here to country, okay, because I'm interested with the data related to the countries, and I have chosen so far 3 countries, although finally I opt for Malaysia only because I'm from Malaysia. And then this is what I have done in order to combine the data, because the data is very huge. It is basically inclusive of all countries, so I just choose some of these interested countries of mine. And then I measure the data, okay, by using many measurement methods such as the mean, okay, the maximum value, the standard deviation, the correlation, the skewness. This is the functional APIs that I have defined, and this is the results. Okay, if you can see here, the results of the measurements here. Okay, the first one is the mean value, okay, and the average, the mean value is 2,300 something today, and the maximum value is 6,000 and so forth here. Okay, I have also measured the skewness and the kurtosis values here, and I have visualized by using the histogram here. Okay, this is the histogram that we can see here. We can see that quite a lot of cases which is quite low that happened in Malaysia. This is what I got from Malaysia, the cases in Malaysia, the confirmed cases. And this is the box plot, our special plot here, and we can see the standard deviation is somewhere here slightly below the 1000. Okay, and the feature engineering, I have actually decided to use time steps because this is a time series data. Alright, and then the next thing is about the model algorithm. I've used ILSTM algorithm, okay, which is very suitable. It's a deep learning algorithm, one of the best algorithm in deep learning, and it is used for time series. So I use this one, and I use the framework TensorFlow, okay. And I also use another one to compare with a non-deep learning algorithm, which is multinomial logistic regression, which I will show to you very shortly. And then this is the model performance indicator. I use TensorFlow again to find the mean absolute error, and it is very good. And then this is accuracy also is used to measure the performance, especially for the multinomial logistic regression algorithm. This is what we have done in the ETL in order to do the extract and transform and load, where I have converted the file into Parquet, and I save it in the IBM cloud storage here. As you can see here, I have loaded here. Okay, I have save here in the right. Basically, this is what we do in order to save it in the object storage of IBM, and then I load it. And then finally, I've done the training, the modeling and training by using the LSTM, as you can see here. Okay, so this is our last part, okay, of our presentation, where we I'm going to show to you our results here. All right, you can see here, this is the mean absolute error that I have obtained by using the TensorFlow Keras, okay, which is done for 300 epochs, and the step size is 5. Okay, and then this is quite okay. Okay, it is converging, and it is reducing after 300 epochs, and okay, which is very good. And then the next thing is I use the non-learning, the logistic regression here. Unfortunately, it is not very suitable, although I have made a lot of changes. So this is basically summarize that deep learning is very suitable, LSTM, for this model. I think that's all for today. Thank you for sharing and basically listening to this presentation. Bye bye.